All right, so let's get started by talking about infinity as a horizontal movement, a left-right movement. And in order to do this in a good hands-on way, we're going to go back to the function of sine of x divided by x. And I have that here for us to look at again. Remember in the first lesson, and let me get rid of our lower third here. There we go, now you can see. In the first lesson, we talked about this graph as we were trying to let x get closer and closer to 0. So we were looking at, let's see if I can make a little mark here for us. We're kind of looking at the graph right here as it's getting closer and closer to 0 because we did say that there was an error involved in it, and we wanted to figure out what y value we were getting close to. However, that's not what we really care to look at right now. So actually I'm going to take this little spreadsheet and move it over. What we are concerned about right now is what happens to this graph, not as it moves towards the center, but as it moves outward in the right and left direction. So before we talk about that, I want to make a very important point, which is we often think about infinity as a number. Like, the reason I say that is this right here is the symbol for infinity, right? And it's very easy to just write it down and assume that it's kind of like the number 10 or 100, like it's the value of infinity. But infinity doesn't work that way. Infinity isn't a value, it is a movement. So it's a movement towards greatness, for a nice philosophical thing you can ponder there after we're done with this lesson. Infinity is a movement towards greatness. You never completely arrive at infinity, but you continue to let it grow and grow and grow. So anytime that we're talking about infinity in these mathematical problems, we're not talking about a specific point on the graph, we're talking about a movement on the graph in a certain direction. So for instance, let's go back over to our graph. In positive infinity is the movement of this graph outward, let me do this here, outward in the right direction. And that would be infinity. Negative infinity is the movement of this graph outward towards the left-handed, the negative infinity direction. And I can scroll out, or I can scroll in or out, so that I can get a better view of what's going on here. And the further I go out, the more aware I am of the fact that this graph, as it approaches actually either positive infinity or negative infinity, is approaching the limit of 0. So let's think about that for a second. We have a graph that is, we have a graph that is, kind of starts out here at 1, y equals 1, comes down, oscillates, comes back up, then oscillates a little less, a little less, a little less, and as we zoom out from that picture, we see that the graph itself is approaching, ever so slowly, a value of 0. Now, does the graph ever become totally flat and reach 0? Well, from our knowledge of mathematics and patterns, we're going to say no, it never completely levels out as it goes towards infinity, but it becomes so close to becoming flatlined, essentially, that we're going to go ahead and say that the limit of this function, as it approaches infinity, actually from either positive infinity or negative infinity, the limit of this function goes to 0. So how do we write that? Let's see if we can write out what we're talking about here. We're saying we have a function, sine of x over x. And the question that we were asking ourselves before we looked at that, that picture is, what is the limit as the x value goes to infinity? Oops, that should be an arrow. And what is the limit as the x value goes towards negative infinity? And those are two different things, because even though they're both a movement towards greatness, one is a movement towards things that are greatly positive and the other is a movement towards things that are greatly negative, and that certainly, if you think about money, that definitely does make a difference, right? So we have the possibility of getting two different answers here. Now, if you are thinking back to what we just did, we don't get two different answers, but that's okay. We could get two different answers because they are two different questions. So we said, what is the limit of what this graph is approaching as x is going towards infinity? And we said it is approaching a value of 0. Now, does it ever get to 0? No, it never actually officially gets to 0. But as we move towards infinity, it gets so close. I mean, it's going to be like 0.00000000001 away, and more. Actually, it's going to get even closer than that. But it's going to get so close that we can say it is essentially 0. The limit is 0. And the same is true in the negative direction. And that's it. So what's interesting about this is that we're asking a question that involves infinity, and we're getting an answer that's just a normal number. Like the graph could have approached 1, or it could have approached 5, or it could have approached 10. But as we move towards infinity, the graph is approaching an actual solid physical number that we can identify. And that is how infinity in left-right directions work. Now let me just think, do I want to add anything else in here? Yeah, let's actually add in a little example. So let's go back to my little blank sheet here. Actually, I need to clear it out. And let's use this new example. We're going to try to find the limit as x moves towards positive infinity of a rational function. So this time we're not talking about it in terms of the graph. We're looking at it in terms of the function. So 4x squared minus 3x plus 5 all over 2x cubed plus x minus 1. So typical rational function. We want to ask ourselves the question of what is happening to this graph as it moves towards infinity. Now, we don't really want to rely on our graphing calculator because that's not a good sign for mathematics if we need our graphing calculator to tell us the answer. It means that we don't really understand the math behind it. So let's see if we can figure it out just from the numbers and the variables. In order to do that, we have to think about how numbers work. When we move towards infinity, if I have infinity and I multiply it by 3, where am I getting that? I'm getting that right here, this whole idea that there's a x that's being multiplied by 3. Let me remove that because that's going to bug me. If we take infinity and we multiply it by 3, or negative 3, we don't change the value of infinity that much. I mean, we do a little bit, but not that much. If, on the other hand, we take infinity and we square it, we are going to outpace that infinity that's just multiplied by 3 so fast it's going to just be left in the dust. In fact, if we also were to take infinity and cube it, that movement would way outpace the multiplying by 3 as well as x squared. In fact, if we were to go, let's say, take infinity to the 4th power, or to the 5th power, or to the 6th power, we can create a movement toward infinity that so far outpaces anything below it, mathematically speaking, that we can basically ignore it. You don't hear that too much in mathematics. Like, just take the little numbers and just ignore them because they're not that important. That's what I'm about to tell you. So watch how this works. Prepare to be shocked and amazed and possibly troubled by what we're about to do. Okay, so we are saying we can't plug in infinity as a number because infinity isn't a number, but I'm going to kind of use that as my notation right now, with the caveat that you're not really allowed to plug in infinity. So we're going to say infinity squared here instead of x squared. We're going to talk about regular old infinity here instead of just x. Down in the bottom, we're going to talk about infinity cubed instead of x cubed, and we're going to talk about infinity. So as we're moving towards positive infinity, essentially these are not the numbers, we're not plugging in, these are the movements that we're talking about. Now, in light of all this infinity stuff, on the top, we have to ask ourselves, is plus 5 really going to affect our answer at all? I mean, if we're dealing with infinity squared, plus 5, I mean, the plus 5, we're not even going to notice it. So we are going to, we're just going to make it go away. We're just going to pretend it's not there because it's not really important. It's too small to be important. In fact, in the same, on the same note, -1, we're dealing with infinity cubed over here. -1 is not going to change our answer that much, so we're just going to, make that go away too because it's not really that important. All right. Don't anybody faint on me yet. I know this is like kind of sketchy mathematics, but it works. It really does. Okay, now let's compare infinity to infinity squared. And we were just talking about this, infinity as opposed to infinity times infinity. I mean, we all learned this on the playground as kids, right? Like somebody's like, I did that to the times 100. And then somebody would be like, no, I did it times infinity. And then somebody says, I did it infinity to the infinitieth power. And then they obviously win because you can't outpace infinity to the infinitieth. So it's the same thing here. Infinity, 3 times infinity, is basically like nothing compared to 4 times infinity squared. That's moving way faster than this, so we are going to forget about it. Just let it go. And we're going to do that on the bottom too, because infinity as opposed to infinity cubed, that's really not that important. So now that we've broken this down, and you're probably peeling yourself off the floor because you feel like I am really breaking some serious math rules here, we really have brought this down to the limit as x goes to infinity of just 4x squared over 2x cubed. Oops, that's an x. Because everything else is growing so much more slowly than anything else that we've talked, or than these two, that it doesn't really matter. So we really only care about these leading terms here, 4x squared over 2x cubed. And using that, we can kind of reduce this with our knowledge of mathematics, and we know that this is really 4 over 2 is the same as 2 over 1. And I imagine the 1 is there, but x squared over x cubed is really the same as just 1 over x, right, if we cancel. So this reduces down to, I shouldn't really say equals, I should say arrow. We're turning this into 2 over x. So the limit as x goes to infinity of 2 over x. What number are we approaching when we have x growing towards infinity and 2 in the numerator? So let's think about that. I'm going to write that here. We're basically looking at, oops, I have my pen. Limit. Oh, it is working. Sorry. You probably can see that and I can't see it. Let's use darker color. That would work a lot better. We're going to do the limit as x goes to infinity of 2 over x. And what is the answer? That's what we want to know. Well, again, let's think about what's happening to this number. If I take 2 and I divide it by 1, I have the number 2. If I take 2, I double the x value. I say 2 divided by 2. Now I have an answer of 1. Let's double it again. If I have 2 divided by 4, I'd have 1/2. 2 divided by 8, I'd have 1/4. 2 divided by 16, I'd have 1/8. 2 divided by 32, I'd have 1/16. So my answers are going 2, 1, 1/2, 1/4, 1/8, 1/16, and then we'll go 1/32, 1/64, and so on and so forth. It's going to get smaller and smaller and smaller, which is really getting closer and closer and closer to 0. Because if I were to find the decimal value of that, I would be getting a decimal value that's smaller and smaller and smaller and smaller and smaller and closer to 0. So as we take x and we make it bigger and bigger and bigger, in fact, reaching to infinity and beyond, to coin a phrase, we have a fraction that is approaching a very, 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 very small quantity. In fact, the quantity of 0. It's approaching 0. So the limit as x goes to infinity of our original equation, let's look back at what it was. It was, oh, I kind of erased it. It was 4x squared minus, was it, I think, 3x plus 5 over 2x cubed plus x minus 1. It is officially approaching 0. And that, my friends, is kind of frightening, I know. Put it there too. The limit as x goes to infinity, in this case of the reduced 2 over x, moves towards 0. We have much more to talk about in this area, but I'm going to leave you at that for this first topic video. And in the next video, we're going to talk about movement towards infinity in the up and down, the vertical direction, and see how that's similar and how it's different. So stay tuned for that.